area is the sum of all the faces the face areas, I suppose, of a solid.
What does the sum tell you we're going to do? Add together, good. And then it says the we used that word yesterday a little bit. What does a solid mean? Like a 3D object, good. And then what do you think face areas mean? The sides, the outside part, good.
So we need to identify like how many outside parts are there going to be of a prism. So we're going to go back to my hexagonal prism here. How many bases does a hexagonal prism have? 2, the front and the back, right? But when I open that up, and some of you already opened yours up, we have what's called a net. And a net is when we take that shape and we like unfold it and we see that it's all connected together. Okay, because I have a hexagon, how many rectangle sides are there ending up being? Yeah, because I'm covering them right now.
Okay, well, let's go back up for a minute. How many hexagon sides do you see? Okay, don't go back onto your phone. That's why you missed them the first time.
So you have 2 hexagons. How many rectangle sides are connecting those hexagons? 6. Why are there 6? So how many sides of the hexagon do we need covered? 6. So if I had a pentagon, if I had a 5-sided shape, how many rectangles would there be? 5. If I had an octagon, 8 sides, how many sides would there be? 8. So that's the amount of rectangles or the amount of sides that your base shape has. Good. So to find our area, we're going to talk a little bit more about this formula, where it comes from. We have SA equals, and we use capital letters for SA, equals, and we get 2, and we're going to use a capital B. Plus, and then we're going to do capital PH, lowercase h. Okay, we're going to talk about what each of those things mean. This formula allows us not to have to look at each individual rectangle. So rather than looking at all 6 rectangles and then adding them together, or all 8 rectangles and adding them together, or just 3, we can kind of hack it by working with this formula. Okay, what do you think SA stands for in our notes today? Good, surface area. Good. Do I need to write that next to it? You guys know it's surface area? Okay. So we have 2, and then we have B. B, the capital B, stands for the area of the base. Okay, I'm seeing a lot of phones out. We need to put those phones away. Today is kind of a lot, especially those of us that need to get caught up in the notes. Maybe. All right, how come we have 2B? When I look at my hexagonal prism, why do I have 2 of the hexagon areas? Why do I have 2 bases in my area? Why is it 2 times base? Yeah, because there's 2 of them. When we opened it up, how many hexagons are there? 2. Now, to find the areas of these rectangles, rather than finding the area of each rectangle and adding them together, we know all these heights of these rectangles will be the same, all these lengths, because they go the same amount across. So what we need to find is how far it is down this big long rectangle, if we look at it as one long rectangle, which is kind of hard to do with a hexagon here. But that's the only one I have left. So we're going to find this height, and then we need to find the whole length of that rectangle, all the way down. So how can I find that whole length of the rectangle? Yeah, I can measure it. What does it line up with? It lines up with the sides. And what do we call that when it goes around all the sides? So it really goes all the way around those sides. The perimeter. So to find the area of this long rectangle in the middle, we're going to do the perimeter, because that's really this length here, times this height. So the capital P stands for perimeter of the base. Maisha, write this down. And the H stands for the height of the solid. Which the height of the solid is really the amount between the bases. Now what gets a little goofy here is as we find these areas and these perimeters, we might use 2 different heights as we go, because we might have a height of just the base, and then we might look at just the height of the whole solid. And sometimes those heights are different. So as we work, we have to think one by one each one. All right, you're going to get a glue in. You should put it on one side of your page, either on the left side or the right side, because we're going to show our work on the other side.
It just has 3 shapes on it. You shouldn't have to cut it, but if your formula was a little bit bigger, you can't quite fit it on your page, you can cut it on one off.
And put it on the next page. Don't just cut it off, right?
Cut it off.
Just cut it off. No. Don't do that. Alright, as you get your glue out, I am going to be using 2 highlighters today, so you could use 2 colored pencils, maybe that are light colored, or you could grab out 2 highlighters. If there's not enough highlighters for everyone, you could share. You have one color, your partner has another, and then switch when we switch colors. Yeah. Alright, we're going to get started in about 30 more seconds, so pass those glue sticks around. I'm going to be using yellow and orange highlighters today. If you'd like to use the same colors, you can. Or just grab 2 highlighters and just switch colors when we switch colors. We still have like 20 seconds of the 30 seconds. Alright, in this first shape, what kind of prism do we have here? What's our bases? What's our base shape? Somebody said it. What did you say, Jack? Did you say it? No, you didn't say it. Never mind. Somebody said it. What's our base shape here? Is it a rectangle, a triangle, a square, a hexagon, pentagon? Triangle. Good. So what I'm going to do is with my orange highlighter here, I'm going to highlight one of the triangles. I'm going to start with just highlighting one. If you want to highlight both, you can. These triangles just have like a weird overlap to them, so I like to only highlight one in this case. All right, so we need to find 3 parts of our formula. We need to find the area of the base, the perimeter of the base, and then the height of the solid. So I'm going to start with my capital B, my area of the base. When we find the area of the base, we have to go back to our chapter 11 notes sometimes. What shape is the base? It was a triangle. So what's the area formula for a triangle? Good. A equals 1/2 base times height. So as I do my area of my base here, I'm going to do 1/2 times. Now my base and height of a triangle have to make what? A right angle. So when you look at this orange triangle, we're only looking at the orange triangle. What 2 sides make our right angle? Where do you see that? 90-degree angle. Right there. And what 2 sides come together right there? We have 7 is connected to that, so 7 will be one of them. And then what's the side that makes the 90-degree angle with that? Yeah, it's this dashed line going up this side. How do we know that this side is 11? Good, because it's a rectangle here, so we know opposite sides are congruent. So this is really 11. So if you need to write an 11 there, that's really 11. So we're going to do 1/2 of 7 times 11. I'm going to use my Desmos calculator today. One half times 7 times 11, and we get 38.5. Now that's where we would have stopped last chapter. We just had to find the area of the triangle, but now we're finding all the areas, all the outside parts too. So now I'm going to find my P. P stands for my perimeter of that base. So again, I'm just looking at my orange triangle. I need to add the outside parts of that triangle. So I know one side is 8. So I'm going to do 8 plus, what's another side? 7 is the height.
6.
Is 6 part of this outside, this part we highlighted? Yeah, 10, because 10 is across from here, so we have this 10. So we're going to do 8 plus 10 plus, what's our other side? 11. Okay, 8 plus 10 plus 11. It's 29. Okay, now we need to know the height. Now, we identified the height of the triangle as 7, because that went across the triangle. But this height, I need the height of the base. So I need to know what's the space between the triangles that connects them. And Jack had it. Yeah, what was it? 6. Okay, so if you need to re-highlight that, that's our 6 there. Okay, remember if you don't have enough highlighters, you can always switch with a partner when we switch out colors. Alright, so now we're going to follow our surface area formula. So our surface area formula starts with 2 times the area of our base, our big B. So what number do we have for our big base here? 38.5. And we have 2 of them because how many triangles are there? 2 triangles. Okay, then if we unfolded it, we'd get this really long rectangle that connects those 2 triangles. So that formula for that area would be base times height, but the base is really our perimeter. So we're going to do perimeter 29 times the height of the prism. Which, what did we say is the height? We said it was 6. Alright, so if I plug that in, we have 2 times 38.5 0.5 plus 29 times 6. We get 251. Now we're still talking about area, so how am I going to label this area? Good. But the way we say it is square centimeters. We'll talk about cubes later this chapter. Cubed is when we talk about volume, how much fits inside. This one we're still just talking about how much space does it cover if we unfolded it. All right, if you like to draw your lines, you can draw your line across there. Show that we're done with that one. All right, next up we got another prism here. What kind of prism is this next one? Not quite a square. It's a rectangle. It almost looks like a square, but it's a 6 by 5, so we know it's a rectangle. Okay, so we need to identify which one is our base. And now with a rectangular prism, it gets a little tricky. Not tricky. There's just a lot of options. Because it doesn't matter which rectangle we pick to be the base. So we could choose this bottom one, this 5 by 6. We could choose this side one, this 5 by 9. Or we could choose kind of like this front one, this 6 by 9. Which one do you guys want to be your base? The 5 by 6, the 5 by 9, or the 6 by 9? When you look at it, what does your gut tell you is the base? It doesn't matter which one. The 5 by 6? Okay, so I'm going to highlight that in orange, saying that that's my base. If you'd like to highlight the top one too, so that you see that those are the congruent bases, this time it doesn't overlap, so it's a little bit easier to see the difference between them.
Remember, you easily could have chosen a different one, and if you want to do a different one, you can. Just be careful as we go through it. Your end answer should be the same, but it's going to be different all the way until the very end.
Okay, so we're going to find the area of the base. And this time it's a rectangle. So how do we find the area of a rectangle? Just base times height. So what is the base of this rectangle on the bottom that we highlighted? 5 times, what would the height be then? 6. 5 times 6 is 30. Okay, like Ms. Sutter said, if you picked a different rectangle, you'll get the same end answer, but you would actually get a different answer there. Now we're going to find the perimeter of that base. So we're going to work our way all the way around that base. So I have 5 plus 6 plus, how much is this side going to be? 5. Can you sneak that in there? Plus, what's this last one going to be? 6. So 5 plus 6 plus 5 plus 6. I know 5 plus 6 is 11, so this is really 11 plus 11, which is 22. All right, the last thing we need for our formula is the height of the prism. We use a lowercase h for that. I'm going to use yellow to signify that h, and I'm looking for that space that connects my two rectangles. So as I travel from this bottom rectangle to the top, I'm looking to see how long is that length. And what do we get? 9. All right, so our surface area formula is 2 times the area of our base. What do we have for our area of the base? 30. Plus, and that's our perimeter times our height. So what is our perimeter? 22 times our height? 9. Thank you for those of you that are really focused in. It's a little bit easier to teach over people that aren't having side conversations. All right, 2 times 30 plus 22 times 9. And we get 258. This time, how are you going to label that 258? Not just kilometers, square kilometers. Good. All right, last one here. What kind of prism do we have for this last one? What's our base shape? What? It's a polygon. Good, it's a regular polygon. We see all the sides are the same. And how many sides does that polygon have? 5. So a 5-sided shape is a pentagon. So this is a pentagonal prism. So we're going to start with highlighting in that base. If you want to highlight the bottom one as well, because those are congruent, you can. And this is going to really require us to think way back to chapter 11, which was last week. Way back to last week. If I want to find the area of that pentagon, my base, who remembers what's our formula for the area of a regular polygon? If you need to look back, that'd be the 11-4 notes. Good, we use our apothem and perimeter, but what else? Half. So 1/2 apothem times perimeter. So this is going to change depending on the prism you're working with. And this last one we just did base times height, and the first one we did half base times height. This time it's half apothem times perimeter. Okay. So as I look at my pentagon, I'm going to start with 1/2 times, what's my apothem going to be? Good, it can be either on the top or the bottom because those are congruent, and it goes from the middle to the outside. So that 4.8. And then we're going to do times our perimeter. So what's kind of nice is where you have to find our perimeter anyways. So how am I going to find my perimeter of this pentagon? Yeah, how much is one side? 7, and how many sides do we have? 5. So 7 times 5 is 35. Okay, again, I'm going to use my Desmos calculator. 1/2 times 4.8 times 35. And we get 84. Okay, now there's 2 other things that we need. We need our perimeter of the base, which we actually already found. What's the perimeter of our base? No? No one knows? What was it? 35. Thanks, Gretchen.
We have 5 sides. We know that side is 7. So this is 7 times 5.
Good. Our last part is to find the height of our prism. Remember, height is what connects our pentagons, our bases. So as we look at this connection that connects those bases, all of those should be the same height. And how long is that height? 12. So it's the same as this one. All right, so for our formula here, we're going to say our surface area equals 2 times the area of our base. What was our area of our base? 84. Plus our perimeter. Times our height. So we're just going to use all that information that we already found. Okay, so 2 times 84 plus 35 times 12. Oops, that's 11. There we go. 588 square what? Yards? Okay, real quick before we start your practice, I want everyone to focus up on the board. I want to talk a little bit about that height. It can get a little goofy. Okay, now in our pictures here, all of our heights, these two, which direction did our heights go? Kind of up and down. But when you looked at the triangles, which way did their triangle height go? Kind of went back. It was kind of like that depth. When you look at it, it really depends on how your prism is standing. So if it's standing up and down like this, yes, your height goes up and down. But if it's sideways like this, your height actually goes sideways. If it's facing kind of backwards, it's going towards the back. So when you look at that height, you really have to think, where are my congruent bases, and what's that space that's going between them? Does that make sense? So sometimes it's going up and down, sometimes it's going side to side, and sometimes it's like working its way backwards. You have to really take a look. All right, that is it for your notes today.